Signage and Wayfinding Design, a complete guide to creating environmental graphic design systems by Calori and David Vanden-Eynden. Chapter 3, Overview of the Signage Pyramid Method. Making the complex simple by using a systematic approach. As explained in Chapter 2, the design process. The design of a comprehensive signage and wayfinding program is a very complex undertaking, more complex than most people, including those in the broad spectrum design community, might imagine. So how can EG designers approach a signage problem and begin to chase down a successful solution? By using the signage pyramid, a methodology we outline in this chapter and delineate further in the next 3 chapters, it is an effective, systematic, proven approach to mediating the problems and subproblems associated with the design of a comprehensive static signage program. Calori initially developed the signage pyramid approach in her graduate school studies and thesis, and we have since noodled with and fine-tuned it through years of practice at our design office. Although many people think we're crazy to share this proprietary tool with our fellow designers and competitors, with the first edition of this book, the time has come to contribute it to the growing body of knowledge about EG design. As pointed out in Chapter 1, when Chris developed this approach, the terms signage and environmental graphic design were just coming into use, and the field was just progressing from its infancy to toddlerhood. The Society of Environmental Graphic Designers, now the Society for Experiential Graphic Design, SEGD, has been formed a few years prior to Chris's graduate studies, and very little information was available on how to approach EGD problems. The notable exception to this knowledge gap was the groundbreaking book, Architectural Signing and Graphics, written by esteemed pioneers of the field John Follis and Dave Hammer in 1979. Genesis of a design approach. In our professional careers, after receiving our undergraduate degrees, we gravitated from 2-dimensional print to 3-dimensional signage design because we found the 3D aspect of signage to pose more interesting design challenges than print work. Chris's first foray into the signage world was as a member of a design team that was developing the signage for a large, new international airport being built overseas. The team consisted of graphic designers and architects working within the corporation that was designing and building the airport. In the early phases of that project, the signage team focused primarily on the design of the sign graphics, based on a limited list of messages and the sign objects that would display those graphics. During the design development phase, the team began to develop the actual sign messages and locations that would be needed for people to find their way through this very complex airport environment. In the process, the number of messages that had to be displayed on the signs grew from one to many, and this required a fundamental alteration in the design of the signs from the one conceived during the schematic design phase. Chris somehow believed that this amount of backtracking shouldn't be necessary, and so decided to take her budding professional EG design experience to graduate school to analyze what's involved in EG design, and to figure out a way to approach it more seamlessly. Thus, the signage pyramid approach was born. The signage pyramid's component systems. During Chris's graduate ruminations, she deducted that the primary purpose of a sign program is to communicate information about a given environment to users of that environment, and that information is conveyed via graphics displayed on physical sign objects or hardware. From that, she came to realize that the design of a signage program is composed of the design of 3 constituent yet interrelated systems as shown in Figure 3.1. the information content system, the graphic system, the hardware system. Comprehensive sign programs consist of many types of signs, from large exterior freestanding pylons to small interior wall-mounted plaques. A key design problem is how to create a unified family resemblance, both informationally and visually, among all the various types of signs in a comprehensive program. The signage pyramid does just that. It provides a balanced three-pronged solution to this problem. Basically, the signage pyramid approach is a classic divide and conquer strategy for solving a complex problem. By breaking down a complicated, nebulous, seemingly insurmountable signage problem into its component parts, each of those parts can be more readily solved. The signage pyramid method views all signage programs as composed of the three distinct but interactive systems, itemized above, that must be balanced in the design process. Each of the systems is outlined briefly here. The information content system. The communication of information is the functional essence of any signage program. Therefore, the information content system consists of what information is displayed on the signs, how the sign messages are worded, where the sign information is located, how the messages and locations of the various signs in the program relate to each other in a consistent, cohesive network of information. Figure 3.2 represents the information content system component of the signage pyramid. The graphic system. The graphic system is the two-dimensional vehicle that visually encodes and displays the information content system. The graphic system consists of what two-dimensional graphic elements, typography, symbols, arrows, and color are used to encode the sign information, how the graphic elements are arranged into layouts to organize the information content, emphasize messages, and create a visual identity, how the graphics are applied to signs. Figure 3.3 represents the graphic system component of the signage pyramid. The hardware system. The hardware system is the collection of three-dimensional physical sign objects that display the sign information as encoded by the sign graphics. The hardware system consists of the three-dimensional shapes of the signs, the size of the signs, how the signs are mounted or connected to other environmental objects, the materials, coatings, finishes, and lighting techniques used, the stylistic relationship of the sign objects to one another and their surroundings. Figure 3.4 represents the hardware system component of the signage pyramid. System roles. Each of these systems plays a distinctive role in the development of a sign program, yet they all interact with each other. The information content system is the underlying reason for a sign program to exist. Sign information is not tangible per se, it's the raw communication material that makes a sign program work. In this respect, the information content system can be thought of as the software of a sign program. You can't see it or touch it, but the sign program wouldn't be functional without it. In contrast, the graphic and hardware systems exist to make the program's information content visible and concrete in the built environment. Given that the information content system is the bedrock of a sign program, the development of this system, often called programming, is a more planning-oriented than design-oriented activity. As such, the information content system should be mapped out and planned before design of the graphic and hardware systems begins in earnest. Why? Because any design activity will be somewhat meaningless and therefore wasted if the extent of the information content system for which the graphic and hardware systems are being designed is unknown. Take, for example, the design of a drinking vessel as a very simple analogy. The type of liquid content, whether water, coffee, beer, wine, or a cocktail, and the quantity of liquid it can contain will obviously have a profound influence on the design of the vessel. See Figure 3.5. Should it be thick or thin-walled, stemmed or not? Large or small, glass or ceramic or plastic, equipped with a handle, and so on. Without knowing the intended contents, the designer would very likely spend a lot of time designing a vessel that's completely inappropriate to its required function. The same applies to designing a sign program's graphic and hardware systems before the EG designer has developed the information content system. Accordingly, the information content system is the foundation, the planning that needs to be substantially in place before design of the graphic and hardware systems commences. Therefore, design of the graphic and hardware systems takes place concurrently in a back and forth manner. Additionally, the information content system may be further refined or tweaked as the design of the graphic and hardware systems progresses. System interactivity. So much for the differences between the three systems of the signage pyramid. Now, how do they interact? The information content system is the bedrock, the raw informational material that is communicated by the graphic system, which in turn is displayed on the hardware system. Let's examine a few examples of this interaction. For starters, sign locations and messages, part of the information content system, have a profound effect on the size of the graphics for a given sign, as determined by factors such as reading distances for the graphics and the length and quantity of messages. The size of the sign graphics, in turn, affect the size of the sign hardware that displays the graphics. The sign location aspect of the information content system can also directly affect the hardware system, in that the location of a given sign can determine how long the sign object can be and how the sign is mounted. Sign size and mounting are primary formal factors in the hardware system. The graphic and hardware system interact in terms of visual appearance factors such as style and color. There are many other ways in which the three systems of the signage pyramid interact with each other, as will be seen in chapters 4 through 6. The signage pyramid method that this book delineates for designing static signage programs can also point to an approach to digital information systems. In this approach, the digital realm's information content system would be the information being communicated. The graphic system would visualize the information in 2D graphics and/or video, and the hardware system would deliver and display the information on 3D electronic screens. The signage pyramid and resource allocation. There's no doubt that all design activity, including EG design, involves a certain amount of backtracking. One step backward for each 2 or 3 steps forward, as the designer progresses from initial concept to final product. But the signage pyramid approach can help reduce the amount of backtracking encouraged when solving complex signage problems. And this translates into more efficient use of the EG design team's time and therefore design budget. At the outset of any EG design project, there's a big temptation on behalf of both the designer and the client to rush into creating design concepts, that is, the pretty pictures for sign, graphics, and hardware. But too often, this just results in finding out later that the concept won't work at various sign locations or for the quantity and nature of information various signs need to contain. Don't fall prey to this temptation. Keep in mind, the sign information content system is intangible, meaning it doesn't lend itself to sexy visualizations, nor is the planning of the system as creative as design of the graphic and hardware systems. But by gritting your teeth and tackling the information content system first, you'll find the subsequent design of the graphic and hardware systems to be far more focused, hence effective. Think of trying to design a book or a website without having the information, or at least a good idea of the information. These items are to contain. Without the content, designing that book or website would be a waste of time because the design of these items is so intrinsically linked to the quantity and nature of the information they contain. The same holds true for designing a signage program. It's a waste of both time and money to design the program's graphic and hardware systems without the informational content. Not only can the signage pyramid approach help allocate design resources and budgets, it can also help in allocation of fabrication budgets. The way the information content system affects fabrication budgets is essentially a numbers game. The more sign units required to communicate the sign information, and the bigger the signs must be to hold all the required information, the more expensive the job will be to fabricate. The point? Take care not to oversign an environment. The graphic and hardware systems affect fabrication budgets differently. Generally speaking, sign quantities and sizes aside, more of the cost of fabricating a sign is tied up in the three-dimensional hardware system than the two-dimensional graphic system. This is due to the cost of the hardware system's raw materials, such as aluminum and steel, the cost of working those materials into the final sign objects, and the cost of installing the sign objects at the project site. In a freestanding overhead freeway sign, for example, most of the cost goes into building and installing the three-dimensional hardware structure that supports the sign panel that displays the message graphics. Even though often these sign panels contain only a few words. In general, the simpler the detailing of the hardware system forms, the less expensive are the sign objects to fabricate. For example, a flat sign panel is cheaper to produce than a curved one. Rich detailing of the graphic system, however, has less impact on fabrication costs. See figures 3.6 through 3.8. These facts can help the EG designer allocate fabrication budget resources. If the fabrication budget for a given project is limited, the EG designer may consider designing the sign program to be driven by the graphic rather than the hardware system. In such a case, the sign graphics are the primary design features, as applied to simple flat sign panels or directly to walls. Another strategy for allocating limited fabrication budgets is to concentrate the more expensive hardware system details on a few highly visible showcase or centerpiece signs, and design the rest of the signs in the program with simpler hardware system details. See figures 3.9 through 3.12. The key in such cases is to maintain a formal resemblance among all the sign objects in the program's hardware system, from the splashy showcase signs to the less obvious room number plaques, for example. Chapter Wrap-Up. This chapter has provided an overview of the signage pyramid method for approaching the design of a signage program. This model divides and conquers the complexities of a signage program by splitting it into three different yet integrated systems that are more readily managed and solved. These three component systems are the information content, graphic, and hardware systems. This chapter has also stressed the importance of planning a sign program's information content system before designing its graphic and hardware systems, and has explained some of the ways in which these systems interact. Finally, this chapter has described how the signage pyramid method can aid in the allocation of both design and fabrication budget resources. The next three chapters are devoted to a detailed explanation of each of the component systems of this model, with the aim of providing the EG designer with the tools to effectively solve even the most complex signage problems.